Space, the final frontier.
Hi girls, so this is my first video on space and how you could use maths as part of your STEM research project to talk about space. From my research into space, and it's one of my things that I'm super interested in. I think there's probably three areas that you could focus on. Okay, so the first one that I think you could focus on is rocket science, and basically answering the question, how do you get a rocket into space? Okay, now to get a rocket into space you need to understand Newton's three laws of motion. Okay, so he worked out basically how things move, why things move, how do you make things move, and why things don't move unless a force is applied to them. Okay, and it's really interesting. So here's a rocket. Okay, and to get it to go up you need to push down. Okay, they use this equation here, F equals ma, and Fa is equal to minus Fb, to work that out. Okay, and I'll explain what they mean in the next video, but you might have seen those before, and we'll actually show how they can be applied to build a rocket. A really good drawing of a rocket, as you can see here. This is his third. This is actually his first equation. Yeah, this is the first law of motion. And I'll explain. It looks a bit scary. Here's our friend Sigma again, this dude. But all it means is the sum of. So sum of the forces is equal to 0. I'll explain what that means in practical terms in a little while. And then they actually have a rocket equation here. This one here is the rocket equation. Looks very scary, but it's very straightforward. I'll explain what all of these mean. But this is everything that you need to get a rocket to lift into the air. So there's delta V is equal to VE by the natural log of m0 over m1. Okay, I'm not even going to go into that at the minute. It's very simple when it's explained in simple terms. So I'll explain that one to you in the next video. Rocket science, how do you get a rocket to go up? Really interesting stuff there. The second area that I think is really super interesting is once you've lifted off your rocket and got it into space, how do you get it into orbit? Now there is a big difference between in orbit and in space. Okay, so this is the equation here to get something into orbit. This is the equation to get it to actually escape the gravitational pull of a planet and get it to travel throughout space. It's called escape velocity. So how fast does it need to be going before it actually flies away from a planet and travels through space? So that's really interesting. And you could go into Einstein's theory of general relativity, where he worked out what gravity actually was. So why did that pen fall? He used lots of maths to work that out, so you could look into that if you wanted. So that is orbit and in space. And the third area you could look at is traveling through space. Now the difference between traveling through space and traveling in an atmospherical body, such as traveling in Earth, is that space is a vacuum. So there's nothing in space. There's no sound, there's no air drag on a vehicle that's traveling. So that means that it will continue to travel at a constant speed like this. Okay, it won't slow down naturally like it would on Earth. And I think even if you decide not to do traveling in space, you need to look up these two spacecraft, the Voyager spacecrafts. There's two of them. They set off in the 1970s, and they are the furthest traveling man-made objects ever made. They've traveled 7 billion kilometers. They passed Pluto a few years ago, and they're gone into interstellar travel now. And then Cassini has traveled around Saturn and looked all about the different moons of Saturn. And there's a documentary I watched on it the other day. It is one of the coolest things I've ever seen. Cassini is the spacecraft that took the picture of the Earth. It's called the little blue dot. You should look it up on Google. It's the furthest picture of Earth that has ever been taken from a spacecraft out in outer space, and it's really cool. And one of the coolest things that they use to travel through space is this idea of the gravity assist, where they actually use the gravity of a planet to slingshot around the planet and fire it off the spacecraft off into space. So there's a huge amount of calculations involved in working out the how to get a spacecraft in the right position so that it kind of slingshots around the planet. If you watch the movie Armageddon, they have to slingshot around the moon so that they can land on the asteroid, and this actually happens. Okay, they've landed a spacecraft recently on I think it's one of the Voyager spacecrafts actually. They've landed it on a meteor that is out in the Kuiper belt, which is past Pluto. Okay, so it's so cool, the gravity assist. But there's your three areas I think you can look at into space. You've got rocket science, so how do you get a rocket up into space? Once it's in space, how do you get it to orbit, or how do you get it to escape the gravitational pull of the Earth? And then once you've escaped the gravitational pull of the Earth, how do you get to travel through space? Okay, so there's the three areas. I wouldn't do all three or focus on all three, but I certainly would look into all three, and the videos that I'm going to give you offer more information on those three areas. Okay, so I'm going to explain the equations and the maths that are involved in those in the next few videos.